Welcome back, guys, to lesson 2-2, scientific notation with positive powers of 10. First thing is very important is that we understand what exactly scientific notation is. The definition of scientific notation is a way of writing very large or very small numbers. Scientific notation is always written in this form, A, where A is a number between 1 and 10, times 10 to some power. Okay. The reason for this is we can take numbers that are super large in the hundreds, millions, billions, and write them down into a smaller form. And what that does is sometimes it makes it easier to do operations with them, to add, subtract, and multiply and divide, because it can be crazy to try and multiply or divide with numbers that are so large. So first, we're going to work with turning numbers from scientific notation into what we call standard notation, and standard notation is just our normal way of writing numbers. And then we're going to reverse it. We're going to take something in standard notation and learn to write it in scientific notation. First thing, we're going to take something that's in scientific notation and we're going to turn it into standard form. So they give us this number. Write 5.3 times 10 to the 7th in standard notation. Standard notation just means that they want us to write it out as a larger number. Okay, scientific notation always has a number between 1 and 10 multiplied by a power of 10. Okay, in this case 10 to the 7th. All that means is every time we multiply by a power of 10, we move our decimal point to the right. We make it a bigger number. So our step one to turn something in from scientific notation to standard notation is just to move the decimal point to the right the amount of times that are in the exponent. So we take this 5.3 and we move our decimal point 7 times. 1, 2, 3, 4, 5, 6, 7. Our decimal point now moves from in here to out front. Okay, and we take these blank spots now and we fill them in with zeros. Okay, so this number is actually 5, 3, 0, 0, 0, 0, 0, 0, and we add our commas in after every three numbers. So it's really 53 million. Okay, so that exponent tells us how many spaces to move our number to the right. Okay, and then when we move it to the right, we fill in any blank spaces we have left with zeros, and that helps us to write it in what is called standard notation. Okay, that is standard notation. Sorry about my handwriting. Okay, we're going to take a look at one more example before we have them try. You try them on your own. So let's take a look at another example. Example 2 says write 3.5 times 10 to the 6th in standard notation. So it works the exact same way as the last one. We start out by writing our number 3.5. Since it's 10 to the 6th power, we're going to move our decimal to the right. 1, 2, 3, 4, 5, 6. We fill in our missing spaces with zeros. And then I just like to rewrite the number 3, 5, 0, 0, 0, 0, 0. Put in our commas. And we end up with 3.5 million. Okay, so again, every time we multiply by 10, we move our decimal point one time. So this is like multiplying by 10 6 times, which moves our decimal point over 6 times. Okay, pause the video, try the your turn section, and then come back and check your answers with me. Okay, so let's take a look at the your turn section. Our first number is 7.034 times 10 to the 9th. That means I move it 1, 2, 3, 4, 5, 6, 7, 8, 9. I fill in my missing 6 places with zeros, and then I rewrite my number 7.034, 1, 2, 3, 4, 5, 6. Put my commas at every 3 numbers. 7,034,000,000 is my number. Okay, number 9. I have 2.36. It's times 10 to the 5th, so it's 1, 2, 3, 4, 5. And I fill in my 3 spaces with zeros, so it's 236, 0, 0, 0. Okay, and number 10. It says the mass of one roosting colony of monarch butterflies in Mexico is estimated at 5 times 10 to the 6 grams. Write this mass in standard notation. The only tricky part about this one is remember that if there's no decimal point, the decimal point always goes out in front of the number. So I start there and I move it 6 places. 1, 2, 3, 4, 5, 6. It's just a 5 with 6 zeros afterwards. Okay, 5 million. So it's pretty easy to take them from scientific notation and to write them in standard notation. Now we're going to work in the opposite direction. You're going to take something that's in standard notation and write it in scientific notation. Okay, so now that we're going to work in the opposite direction, we're going to take a number that's written in standard form and we're going to turn it into scientific notation. So we start with the number. We move the decimal point until we get to a number that is greater than or equal to 1, but less than 10. So you want it to be greater than or equal to 1, but you want it to be less than 10. So anything from 1 up to 9.9 works. Okay. However many times you move it, that is your decimal. So in this case, we have 84,000. They moved it 1, 2, 3, 4 places to make it 8.4 because 8.4 is greater than or equal to 1, but less than 10. Okay. And since they moved it 4 places, it's times 10 to the 4th. It's really not that complicated. So let's take a look at an example. The example says the distance from Earth to the Sun is 93 million, I should say miles. Write the distance in scientific notation. So we start with our number, 93 million. And remember that in a whole number, the decimal point goes to the right. I need to move my decimal point to the left until I get to a number that is greater than or equal to 1, but less than 10. So I go 1, 2, 3, 4, 5, 6, 7. Now I'm at 9.3, which is greater than or equal to 1, but less than 10. And I moved it 1, 2, 3, 4, 5, 6, 7 places. So I rewrite it as 9.3 times 10 to the 7th power. Pause the video, try a couple of them on your own, come back, and check your answers with me. Okay, so let's take a look at some problems. Number 3. We have the number 6,400. My decimal point starts at the end. I go back 1, 2, 3. Now I'm at a point where I'm at 6.4, which is larger than 1 but less than 10. So I write 6.4 times 10. And I move my decimal point 1, 2, 3 places, so it's times 10 to the 3rd. Okay, number 4. It's 570 billion. Okay, so I move my decimal point, which starts at the end. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and I'm at 5.7. So it's 5.7 times 10 to, I moved it 11 places. And last is number 5. 9461 000 000 000 000. Start to the right. I move my decimal point over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 to get me to 9.461. So it's 9.461 times 10 to the 12th. Okay, scientific notation is not really all that complex. It's all about how many places you're moving your decimal point to the right or to the left. The next video will go into what happens when you have a negative power of 10. Okay, if you have any questions, please feel free to ask me, comment, or do whatever you have to do.